So this problem is asking us to determine for this system of equations whether each of these ordered pairs is a solution or not. So there's two ways to go about this. One, if we want to check to see if it's a solution, we can just plug it into both of the equations, and it's got to work for both of the equations in order to be a solution. Or two, we could just solve the system and figure out what the solution is. If there is one unique solution, well then there will only be one answer. If, however, we compare the slopes and they're the same, and then we compare the y-intercepts and they're the same, well then there would be infinitely many solutions, and the solution would have to lie on the line. But just eyeballing this, I'm seeing that the slopes are going to be different, so there's going to be one unique solution. So let's look at the first one, 0, 5. This means this is an xy value. So let me put that here. This is an xy coordinate. So my x value is 0 and my y value is 5. So what I would need to do is plug it in to both equations to see if it gives me a true statement. So up here I have -7 times x, which is now 0, plus 2 times y, which is 5. Is it equal to 3? We can put a little question mark there. So, well, -7 times 0 is 0. 2 times 5 is 10. 10 equals 3. Is that true? No, it's not. And if it doesn't work for one of the equations, well, it doesn't work for the system. So this is not a solution. Now, the other way we could go about it is just solve for the solution. We could then continue to work. We could continue to plug these in to see if they work, or I could just solve the solution, or excuse me, solve the system and see what the solution is. Well, I could do that via substitution, or I could do it via elimination. So I'll go ahead and put this in y equals mx plus b form first to solve for y, to isolate one of my variables. So if I have -7x plus 2y equals 3, if I want to solve for y, I would add 7x to both sides, giving me a positive 2y is equal to 7x plus 3. Then I would divide everything by 2. Both sides of the equation by 2. These cancel, leaving me with y is equal to 7/2 x plus 3/2. Well, from here I could substitute this value in. And this might seem like a little bit more work to do, but this is a second way to approach this problem. I would substitute this value in y into the second equation. So my second equation is 2x minus 3y equals 4. Well, if y equals this value, I can substitute it for the variable here. So I'm going to go ahead and write that up here. Well, I'll write it right here so that you can see 2x minus 3 times y, which is now 7/2 x plus 3/2 is equal to 4. And here I would distribute. So I have 2x. The -3 is going to distribute here and to there. So -3 times 7 is a -21/2 x. -3 times 3/2 is going to give me a -9/2. And that is going to equal 4. Well, then, in order to clear my fractions, because I'm not a fan of fractions, I'm just going to multiply everything by my denominator. So I'll multiply both sides of my equation by my denominator too. And when I do that, I have to distribute in. So this would be 2 times 2x, which is 4x. The 2 here is going to cancel with the denominator, leaving me with a -21x. 2 is going to cancel here with the denominator, leaving me with a 9, is equal to 8. And then I can combine like terms, 4x and a -21x, and I'll come up here, is a -17x minus 9 equals 8. Then I need to continue using opposite operations to isolate my variable. So here I would add 9 to both sides, leaving me with a -17x on this side, because these cancel, and a positive 17 here. Finally, divide by my coefficient, and I get x is equal to -1. So it might seem like a lot of work, but I know now that my x value is -1, and I can plug that back in to my original equation, either one of my original equations, to find my y value. So if I take 2x minus 3y is equal to 4, I would just plug this in here. Minus 3y equals 4, giving me -2 minus 3y is equal to 4. And then I can use opposite operations to isolate my variable y. So I would add 2 to both sides of my equation. -3y is equal to 6, and then divide by my coefficient. And y is equal to -2. And solving here through substitution shows us that there's one solution, and it is when x equals -1, y equals -2. So this is our only solution, and the rest of these are not.